All right, this is the 2013 AB exam number 4. This is the derivative graph question. So you're given a derivative graph. This is the graph of f prime, and you're told that f of 8 is equal to 4. Part A says find all values of x in the open interval from 0 to 8 for which f has a local min, and justify. Okay, so mins occur when the derivative changes from negative to positive. This is the derivative graph, and it's changing from negative to positive at x equals 6, so x equals 6 only. F prime changes from negative to positive. Part B. All right, this is the tough one out of these. Determine the absolute minimum of f on the closed interval from 0 to 8 and justify. So you're looking for an absolute extrema on a closed interval. You have to consider your endpoints and when the derivative is equal to 0. Now, we know that f of 8 is equal to 4. It told it to us. So I kind of wrote my table backwards. I did from the biggest x value to the smallest because I'm working this way. Okay? So there's my first endpoint, and then the derivative is equal to 0 at 6 first. So I'm going this direction, and I'm above the x-axis. So that 7's going to count as negative, all right? 4 minus 7 is negative 3. So now I'm here, okay? I'm going to keep going this direction. That is below and to the left. So that's going to count as positive, all right? Negative 3 plus 3 is 0. Now I'm here, okay? Still going to the left, and I'm above. So that's going to count as negative. All right, 0 minus 6 is negative 6. Now I'm here, okay? Going to the left. That stuff right there is above and to the left, so he counts negative. Negative 6 minus 2 is negative 8. That's clearly the smallest number, so that's your answer. You're going to want to write that answer in words. Don't just circle the table like I did. All right, part C. On what open intervals between 0 and 8 is the graph of f, both concave down and increasing, and explain? All right, I've told you this before. I like to think about these in order of derivatives. So I'm going to think about the increasing part first. F is increasing whenever f prime is positive. F prime is positive up here. Okay, so I'm considering these guys only. That's out. Okay, f prime is negative there. And then we want to know when it's concave down. Well, the slope of f prime is f double prime. And this guy has negative slope, and the regions I'm allowed to look at here and here. So 0 is less than x is less than 1, and 3 is less than x is less than 4. F prime is positive, and f double prime is negative on those intervals. And then part D, you're given a function for g. You're told what f of 3 is, and you're asked to find the slope of the line tangent to the graph of g at x equals 3. All right, so here's what you were told. When you derive it, 3 stuff squared times the derivative of the inside. You've got that chain rule right there. And then where I see x, I'm replacing it with 3. That's what happened here. You were told that f of 3 was negative 5 halves in the directions. And then f prime of 3, well, I can pull that off the graph, right? Isn't this the graph of f prime? That's x being 3. And so that right there is f prime of 3, because it's like x comma f prime of x. Boom. Okay. And then evaluate. All right.